Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Zeno of Elea's paradoxes, a set of philosophical problems attributed to the pre-Socratic Greek philosopher Zeno of Elea, have captivated and perplexed thinkers for over 2 millennia. These paradoxes, preserved primarily through the writings of Plato and Aristotle, challenge our intuitive understanding of motion, space, and infinity. They serve as a testament to the enduring power of philosophical inquiry to expose the limitations of human perception and reasoning. This essay endeavours to provide a critical evaluation of these paradoxes, examining their individual arguments, assessing their underlying assumptions, and exploring their implications for our understanding of the world. We will delve into each paradox, scrutinizing Zeno's claims and considering the various responses they have elicited throughout the history of philosophy and mathematics. Section 1. The dichotomy paradox: infinite divisions. The dichotomy paradox posits that motion is impossible because any distance can be divided infinitely. To traverse a given distance, one must first traverse half of it, then half of the remaining distance, and so forth ad infinitum. Zeno argues that, since an infinite number of divisions exist, completing all of them before reaching the destination appears to be an insurmountable task. A critical examination of this paradox reveals that its central claim hinges on the assumption that an infinite series of actions requires an infinite amount of time. This assumption, while seemingly intuitive, is challenged by the mathematical concept of converging infinite series. In mathematics, convergent series possess a finite sum, even though they contain an infinite number of terms. Consider the series 1/2 plus 1/4 plus 1/2, and so on. While the number of terms extends infinitely, the sum approaches and ultimately equals 1. If we interpret Zeno's divisions as representing increasingly smaller time intervals, then it becomes possible to conceive of traversing an infinite number of divisions within a finite time frame. Furthermore, the paradox tacitly assumes that motion is a process involving discrete steps, each requiring a finite duration. However, modern physics suggests that motion is continuous, not composed of indivisible elements. Therefore, the dichotomy paradox claim of impossibility rests on an overly simplistic and potentially inaccurate model of motion. The paradox presents a valuable challenge to naive conceptions of infinity, prompting a more rigorous examination of its properties and its relationship to real-world phenomena. Section 2. The Achilles paradox: a race to nowhere. The Achilles paradox imagines a race between the swift-footed Achilles and a tortoise, to whom Achilles grants a head start. Zeno argues that Achilles can never overtake the tortoise, for by the time Achilles reaches the tortoise's initial position, the tortoise will have moved on to a new location. By the time Achilles reaches that new location, the tortoise will have advanced still further. This process continues indefinitely, leading to the seemingly paradoxical conclusion that Achilles, despite superior speed, will always lag behind. The underlying claim here is that a perpetually diminishing gap between Achilles and the tortoise prevents him from ever closing it entirely. Like the dichotomy paradox, the Achilles paradox relies on the assumption that an infinite number of steps must necessarily take an infinite amount of time. This reliance falters when confronted with the mathematical reality of convergent series. The distances separating Achilles and the tortoise form a geometrically decreasing sequence representing a convergent series. The sum of these distances, despite their infinite number, remains finite. Consequently, Achilles will indeed overtake the tortoise in a finite amount of time. A further complication involves the way the paradox sets up the scenario. It defines the problem in terms of progressive movements toward positions, rather than velocity or the overall motion. Zeno's formulation obscures the simple reality Achilles moves faster than the tortoise. The paradox is less a demonstration of logical impossibility and more a demonstration of how a carefully chosen, somewhat misleading, description can obfuscate a straightforward situation. The paradox, real value lies in forcing us to articulate precisely why and how motion works, rather than accepting intuition as an adequate explanation. Section 3. The arrow paradox. Motionless moments. The arrow paradox contends that an arrow in flight is, at each instant, at rest. Zeno reasons that if everything occupies a space equal to itself at each moment, and if the arrow space equal to itself, then it must be at rest during that moment, since time is composed of instants, and the arrow is at rest at every instant, the arrow is always at rest, and therefore motion is an illusion. The central claim here is that if something occupies a space equal to itself at each instant, it must be at rest. This claim relies on the particular conception of instants as indivisible, static entities. If instants are truly without duration, then it becomes difficult to conceive of motion occurring within them. However, this conception of instants is not necessarily accurate. Some philosophers and physicists argue that instants are not truly indivisible, but rather represent arbitrarily small time intervals. If instants possess a duration, however minuscule, then motion can occur within them. The arrow can move from one position to another during that interval. The paradox also brings into question the applicability of static descriptions to dynamic processes. Describing the arrow's state at a single instant provides no information about its state at other adjacent moments. Motion requires comparison of an object's position at different times. Focusing solely on a single time point makes it impossible to capture the essence of movement, leading to the misleading conclusion that it is at rest. This paradox cleverly forces us to question what it means for something to occupy space at a given moment, and to explore the relationship between instantaneous states and continuous change. Section 4. The stadium paradox. A relativistic quandary. The stadium paradox presents a more complex challenge to our understanding of motion and relativity. It involves 3 rows of objects of equal length. One row is stationary, while the other 2 rows B and C move in opposite directions at the same speed past row A. Zeno's argument, in a simplified interpretation, attempts to demonstrate that a given time seemingly can be equal to twice itself. He argues that a body in row B passes twice as many bodies in row C as it does in row A in the same amount of time, leading to an apparent logical contradiction concerning the duration of the passage. The paradox's core claim isn't in the nature of motion itself, but involves an assertion of equivalence between 2 frames of reference which are in relative motion. A more precise formulation exposes a subtle flaw related to the units of measurement. Zeno employs a counting method for elapsed time, measuring a unit of time by the passing of one object by another. However, this method becomes problematic when considering relative motion. The rate at which objects in row B pass objects in row C is significantly higher than the rate at which they pass objects in row A. Therefore, equating these 2 counting rates to measure time leads to the paradoxical result. The crucial point is that time isn't inherently measured by the number of objects passed. Time must be measured using a consistent standard of measurement independent of the object's relative motion. The stadium paradox serves as a precursor to the concepts of relative motion and the relativity of simultaneity. While Zeno's formulation is flawed, it points toward the counterintuitive nature of space and time. When considering different frames of reference, it is a testament to Zeno's genius that he explored such seemingly abstract concepts, even if his arguments contained gaps in logic. Section 5. Responses and interpretations from Aristotle to modern physics. Zeno's paradoxes have provoked diverse responses throughout the history of philosophy and mathematics. Aristotle, in his Physics, attempted to refute the paradoxes by arguing that infinity exists only potentially, not actually. He proposed that while one can continue to divide a distance indefinitely, the process can never be completed. Therefore, he maintained that motion is possible because it involves a continuous process rather than a series of discrete steps. Aristotle's response, while influential, did not fully resolve the issues raised by Zeno. His view relied on a distinction between potential and actual infinity that some found unsatisfactory. With the development of calculus in the 17th century, mathematicians provided a more rigorous framework for understanding infinite processes. Isaac Newton and Gottfried Wilhelm Leibniz demonstrated that infinite series can converge to finite values, thus showing that an infinite number of divisions can be traversed in a finite amount of time. This mathematical breakthrough appeared to resolve the dichotomy and Achilles' paradoxes by demonstrating that their underlying assumptions about infinity were flawed. In the 20th century, quantum mechanics presented further challenges to Zeno's paradoxes. Quantum mechanics suggests that space and time may be quantized, meaning they are not continuous but composed of discrete units. If space and time are indeed quantized, then Zeno's assumption of infinite divisibility may be incorrect. Furthermore, the act of observation in quantum mechanics can influence the system being observed, further complicating the analysis of motion. Therefore, the paradoxes continue to inspire debate and exploration in fields ranging from philosophy to physics, pushing the boundaries of human knowledge. Section 6, Assessing Zeno's Intentions, Philosopher, or Provocateur. The precise intentions behind Zeno's formulation of these paradoxes remain a subject of scholarly debate. Some historians of philosophy believe that Zeno aimed to defend the monistic philosophy of his teacher, Parmenides. Parmenides argued that reality is a single, unchanging, and indivisible entity. Motion and change, according to Parmenides, are mere illusions of the senses. Zeno's paradoxes, according to this interpretation, were designed to demonstrate the absurdity of believing in plurality and motion, exposing the contradictions that arise from such beliefs. If this interpretation is accurate, then Zeno was not necessarily trying to prove that motion is impossible, but rather to show that our common sense understanding of motion is incoherent. However, other scholars contend that Zeno was simply a skilled dialectician who enjoyed creating puzzles and challenging conventional thinking. According to this view, the paradoxes were not necessarily tied to Parmenides' philosophy, but were rather exercises in logical reasoning. Regardless of Zeno's specific intentions, the impact of his paradoxes on the development of philosophy and mathematics is undeniable. They forced thinkers to confront fundamental questions about the nature of space, time, and infinity, and they continue to inspire new research and insights to this day. Moreover, they exemplify a critical approach to knowledge, questioning established assumptions and pursuing rigorous logical analysis. Section 7, The significance of the paradoxes' enduring relevance. The significance of Zeno's paradoxes extends far beyond their historical context. They remain relevant because they continue to challenge our intuitive understanding of fundamental concepts and force us to refine our definitions and assumptions. The paradoxes demonstrate the limitations of relying solely on sensory experience and highlight the importance of employing rigorous logical and mathematical tools to analyze the world. They serve as a reminder that our perceptions can be deceiving and that our intuitions are not always reliable guides to truth. In addition, the paradoxes are relevant to modern debates in physics and cosmology. Questions about the nature of space, time, and infinity continue to be central to these fields. The paradoxes offer valuable insights into these issues and can help to stimulate new lines of inquiry. For example, the arrow paradox raises questions about the relationship between continuous and discrete descriptions of reality, a topic that is actively debated in quantum mechanics. Furthermore, the paradoxes have implications for our understanding of computation and information theory. The concept of infinity plays a crucial role in these fields, and the paradoxes can help us to clarify the nature of infinite processes and their limitations. The paradoxes' enduring power stems from their ability to expose the hidden complexities underlying seemingly simple concepts. They challenge us to think critically and to question our assumptions, promoting intellectual humility and encouraging a deeper, Understanding of the world. Section 8. Modern formulations and reinterpretations. While the core arguments of Zeno's paradoxes remain unchanged, modern thinkers have offered novel formulations and reinterpretations, often drawing upon advancements in mathematics and physics. For instance, the concept of supertasks, hypothetical tasks that require an infinite number of steps to complete within a finite amount of time, is directly inspired by Zeno's paradoxes. Philosophers have explored the logical possibility of supertasks, debating whether they are truly conceivable or whether they inevitably lead to contradictions. Another modern interpretation involves examining the paradoxes in the context of non-standard analysis, a branch of mathematics that allows for the existence of infinitesimals, numbers that are smaller than any positive real number but not equal to zero. Using the tools of non-standard analysis, it becomes possible to provide alternative accounts of motion that avoid the apparent contradictions raised by Zeno. In particular, it offers a different approach to the concept of infinite divisibility. Furthermore, some physicists have explored the potential connection between Zeno's paradoxes and the quantum Zeno effect, a phenomenon in which repeated measurements of a quantum system can inhibit its evolution. While the relationship between the quantum Zeno effect and Zeno's paradoxes is still debated, it suggests that the paradoxes may have implications for our understanding of quantum mechanics. The constant re-evaluation of the paradoxes through the lens of new mathematical, theoretical, and scientific advancements shows the deep, resilient nature of the original questions of Section 9. The paradoxes as thought experiments a powerful tool beyond their philosophical and mathematical implications. Zeno's paradoxes serve as excellent examples of thought experiments. Thought experiments are hypothetical scenarios designed to stimulate reflection and challenge assumptions. They can be used to explore complex concepts, test the limits of our understanding, and generate new insights. The paradoxes encapsulate the key elements of a successful thought experiment. They are conceptually simple, making them accessible to a broad audience. They are counterintuitive, forcing us to question our pre-existing beliefs. They are logically rigorous, providing a framework for analyzing the issues involved. By presenting seemingly impossible scenarios, the paradoxes compel us to examine the underlying assumptions that shape our thinking. They reveal that our intuitions, while often useful, are not always reliable, and that we must be willing to challenge them in order to achieve a deeper understanding of reality. The value of these thought experiments lies not necessarily in providing definitive answers, but in stimulating further inquiry and promoting intellectual growth. By engaging with these paradoxes, we develop our critical thinking skills and cultivate a more nuanced appreciation of the complexities of the world. The enduring legacy of Zeno's work is that, over 2 millennia later, they continue to provoke profound. Section 10. The enduring legacy of questioning the Pyrrhic victory. Zeno's paradoxes, despite being demonstrably resolvable through modern mathematics and physics, retain a potent grip on the philosophical imagination. This enduring influence arises not from logical invincibility, but from the profound questions they raise regarding the nature of space, time, motion, and infinity. They serve as a persistent reminder that our intuitive grasp of the world can be misleading, demanding continuous scrutiny and refinement of our understanding. While modern advancements have addressed the technical flaws in Zeno's arguments, they have not entirely extinguished the deeper philosophical unease the paradoxes generate. A nagging sense persists that our formal models may not fully capture the complexities of reality, particularly when dealing with extreme concepts like infinity. In this sense, Zeno's victory lies not in establishing the impossibility of motion, but in compelling generations of thinkers to grapple with the fundamental mysteries of existence. They are a testament to the power of philosophical inquiry to expose the limits of human knowledge and to stimulate perpetual exploration. Though his paradoxes might be considered failures in their literal aims, Their success in fostering critical thought and driving intellectual progress is undeniable. In conclusion, Zeno's paradoxes stand as a testament to the power of philosophical inquiry to challenge our most basic assumptions about the world. While modern mathematics and physics have provided compelling responses to the paradoxes, they have not diminished their enduring significance. The paradoxes continue to inspire debate and exploration in fields ranging from philosophy to quantum mechanics, forcing us to confront fundamental questions about the nature of space, time, and infinity. They serve as a reminder that our intuitions are not always reliable guides to truth, and that we must constantly strive to refine our understanding of the world through rigorous logical and mathematical analysis. The true legacy of Zeno's work is not in providing definitive answers, but in stimulating critical thinking and promoting a deeper appreciation of the complexities of existence. They prompt us to embrace intellectual humility and to recognize the limitations of human knowledge, encouraging a continual quest for greater understanding.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.